again, okay? So I just figured it's good to do some examples. The one below is similar to that, okay? The one below, right? We have x minus 7 times x plus 7, right? So we have x times x, that's over here. We have x times 7 over here, minus 7 times x here, minus 7 times 7, it's over here, as you can see. And so we get x squared plus 7x minus 7x minus 49. 49 is 7 squared. We end up with this. Yeah? Question?
Would we have to keep the, would we have to change it to x squared minus the 3 squared, or can we just keep it as x squared minus 9?
Oh, no, x squared minus 9 is fine.
Okay.
Okay?
Thank
Awesome
you.
question. You're welcome. I'm actually, the reason I even wrote 3 squared here, does someone have another question, or?
Yeah, I had a question. So in the second or third example, when you have like x squared minus 9, do you have to write like x equals plus or minus 3 as an answer?
No. I'm just multiplying it. We're not solving an equation yet, though.
Oh, okay.
Okay? You're welcome. That'll come later, actually. That's the fun stuff. Okay, so here we have x squared minus 9, and we have x squared minus 49. I wrote it as x squared minus b squared, as you can see. There's actually, the reason I even voted this way, I mean, you could stop here, or for this one, you can stop here, I mean. There's actually something a little bit more general happening. Namely, we have this product, okay, right? We actually have this product is equal to this, where b is any number. Although I guess if b was equal to 0, this wouldn't help us too much, but even though it'd still be true, this is actually a general formula, so to say. Down here, this is actually a generalization of it, okay? I mean, basically the one above is when a is equal to 1. This is what we get over here for any a and b, although really I guess a shouldn't be 0 either, but that's okay. But these are just like formulas that can be used not only for multiplying, but also when we factor. And that's going to come next. I'm not sure if we'll get the factoring. No, definitely not today. Probably next week, I'm guessing. Here, this is actually another formula, and you can just prove it. You can just prove it using, stop thinking for a second. I'm sorry. You can just prove it by multiplying. And again, I'm not saying you have to memorize this formula. I'm not going to ask you to state it on an exam, especially since the exams are take-home. That wouldn't make much sense, okay? So, but you can. What's good about knowing these formulas is they're also good not only for multiplying, but they're also good for factoring. Essentially, you would use the formula in reverse. I mean, you'll see what I mean when we get to factoring, though. I mean, I don't want to go too much into that now. That'll cause confusion. All right, let's do another example. Oh, wait, before I get to the next one, this is actually what they call a difference of two squares. That's what this is. I mean, I guess technically this would be also. Generally, people say this is a difference of two squares. Okay, here's just another one. I felt better doing another example before I get to that grid box method we'll see. But again, this is just distribution, right? So you know what? Let me put the pen in. That might make it easier. So we have this, x squared times x cubed. We have, right, we're distributing, see? And that's where the first term here comes from. And the second term comes from, we have 4x times x cubed. That's where the next term comes from. We have this term as well. We have 4x times 5x squared, okay? We have 3 times x cubed here. And we also have 3 times 5x squared. So again, you're just basically distributing. You're just distributing. You're taking each term from the first polynomial and you're multiplying it with each term in the second. And again, you're just adding up the results. Come on. There we go. And then, the way you multiply these monomials is just like what we saw in the first slide today. We have x to the 3 plus 2. We have x, for this one, we have 5 times x to the 2 plus 2. Here we have 4 times x to the 1 plus 3, and so on. 4 times 5 times x to the 2 plus 1, 3 times x cubed, 3 times 5 times x squared, so on. Here we have x to the 5th, 5 times x to the 4 we have, 4 times x to the 4, 20x cubed, 3x cubed, 15x squared. So, and again, what I'm doing here is we just rewrote the terms and then we just combine them, as you can see. Like terms, that is, we combine. Okay, good. Yeah? Does someone have a question? Let me see. Oh.
Sorry, I never put my microphone on. I was talking.
Oh, that's okay. That's okay.
When it says find the product of like a polynomial and a polynomial, is the and, does that mean multiply?
Yeah.
Okay.
When it says find the product of, that means multiply.
Okay, thank you.
You're welcome. Any other questions? All right. Okay, now this is another method. Again, the method before was called distribution. You can use that. I've had students prefer that method over this method, and that's fine. This one, though, is what some people call it the box method, some call it the table method or the grid method, but I'm going to demonstrate it using an example, and then I'll write out the procedure for it. And then we'll do some more examples. I mean, there was a worksheet, although I guess it was really more like backup I was hoping to get to, but if we don't get to it, that's okay. But anyway, yeah?
Will you post the solutions to the worksheet if we don't get to it?
Of course, yeah,
All
absolutely.
right, thank you.
You're welcome. So from here, we have 7x plus 1 times x cubed minus 5x plus 1, okay? So here, what we have is this. So what I'm going to do is this. I'm going to make a big grid, like a table like this, where from one polynomial, each term is going to give us a column, as you can see. And from the other polynomial, each term is going to give us a row, as you can see. Okay? So we have these rows and columns, right? As you can see, that's what I have here. Each term from one polynomial gives us a column, okay? And each term from the other polynomial gives us a row. And now, to get the terms in here, as I illustrate here, you're just going to multiply. Namely, we do 7x times x cubed, okay? And that gives us 7x to the 4. That's the entry in this here. Each of these boxes, I guess, or grids if you want, that's how you're going to find the entries in them. You multiply the row and the corresponding column terms, excuse me. So for this one here, we're going to have 7x times minus 5x, which is 35x squared. Excuse me, minus 35x squared. See? Then after that, we're going to have 7x times 1, which is, of course, just 7x. You multiply anything by 1, you get the thing itself back. 1 times x cubed, this thing here, that's going to be 1x. That's going to be just x cubed, right? So we're multiplying row times column term. For the next one, we have 1 times minus 5x here. And for the last one here, we just have 1 times 1, which is 1. Okay, that's fun. But now the question is, okay, well, how do we get the product of the two? We're going to add up the entries in these boxes. We're going to add up the entries in these boxes. That's what we're going to do. So we have 7x to the 4, right? We're adding that to x cubed, right? We're adding plus minus 35x squared, minus 5x and 7x and 1. And we're just adding them all together. That's how we get this. When I added, I know it looked like I went this way, like down, then diagonal, down, but you don't really have to go in that pattern, though. The only reason I went in that pattern was because I want my answer in standard form. Okay? And also notice that these were like terms. Sometimes on diagonals, you'll get like terms, but not always, though. Let me just do a